Problem 62, Unique Paths. So to solve this problem, we need to know one concept, and that's DP. DP is all about building solutions on top of solutions, and we'll see this in action with the example. So we're given the example of a 3x7 board, and we're trying to reach the bottom right corner using just right and down moves. So how do we do that? Well, let's first condense this problem into a simpler problem, which is, let's consider a 2x2, right? Let's consider a very simple grid. How many ways are there to get from the starting point right here to the end point? Well, that's pretty difficult. Let's simplify the problem even further to just consider a 1x2 board. If this was the starting position, how many ways are there to get to this position? Well, there's only one, because I can only move right by one. Well, what about, by extension, this grid right here, a 2x1 grid? Well, it's the same thing. There's one way to go here. So we can fill the positions out in these two circles, right? It's going to be 1 and 1. So with that, how do we get to E? Well, E can be achieved in one of two ways. It can either be achieved by going from here to here, right? That's 1, or here to here. That's 2. So what does that mean? It means that to get to this position, it depends on knowing how many ways are there to get to this position and this position, meaning it's going to be the sum of those two positions. So E is going to be equal to 1 plus 1 is equal to 2. I think we're onto something. So with this, let's actually extend this to a 3x7. Let's extend it by 1. How many ways are there to reach this grid? Well, there's only one possible path. We just keep going right. So there's only one way here. And what about for this position? Well, same thing. There's only one way. We keep going right. So we see that for the 0th row, it's always going to be 1. There's only one way to get to each of these positions from the starting position. So we have a 3x7, so that's 1, 2, 3, 4, 5, 6, and a 7. That's going to be the grid for that. But we also know, by extension for the columns, that has to be 1 as well, for all columns that are equal to 0. Now, this is equal to 2. Then what must this grid be? That must be 2 plus 1 is equal to 3 by the same logic of how we got 2 for the 2x2 case. So we basically, what we have to do is we're just going to keep iteratively summing up these positions until we get 15, 21, 28, which is the answer that they got right here. So with that, we can program it in Python. So as we defined, we're going to need a grid, or rather a 2x2 array, to store all of the possible paths to reach each position, and they're going to correspond with each position on the original grid. The grid is defined by m and n, where m is the rows and n is the columns. So let's say the array is equal to 0 times n, right, for underscore in range of m. That's going to initialize a 2x2 array with m rows and n columns. So what do you do next? For I in range 0 to m, we're going to do row-wise. For j in range 0 to n, what can we say? If I is equal to 0 or j is equal to 0, that must mean that the position, the number of ways to get to this position has to be 1, as we saw previously. But what if this is not the case, right? What if we have I is not equal to 0 and j is not equal to 0? Then that must mean that to get to this position, it's dependent on the number of ways to get the leftmost position, which is I minus 1j, summed with the number of ways to get to the upper position, which is ij minus 1. And that's it. That's the logic we did, and that's the logic we implement. So we return the array at n minus 1 and n minus 1, and we're done. So let's run it. And we're good, so let's submit. And that's the solution.